12.2. This next one is a graphing calculator problem. They want us, it's example 7, to graph this equation using a graphing utility to check your work. Okay, graphing these by hand, it's really not all that necessary except that you get the idea. But what you've got to do to put this in your calculator is you've got to take the square root, which ends up giving you plus and minus. It's two curves. Now, when you do this on the calculator, you're going to put it in as two separate equations. If you were doing this by hand, you'd have to pay attention to the fact that the cosine of theta has got to be greater than 0. And so in this case, it's only going to exist when I'm graphing from 0 to pi over 2. Because once I get past pi over 2, it starts going negative. So I'm going to be going from 0 to pi over 2, and then I'm also going to be going, the next time it's positive, is from 3 pi over 2 to 2 pi. And I know that because all students take calculus. It only happens in quadrants 1 and 4 for looking at the trig. Now when it graphs, it's going to graph it in all the places because we have plus and minus. So on the graphing calculator, you're going to have to go to the mode and change it to polar. And then you pick y equals. So you went to mode, and then you fixed it to say polar. And then you went to y equals, and notice it says r sub 1 equals, and you're going to have to put in 3 the square root of the cosine of theta, and then you're going to have to go down to r2 and put negative 3 the square root of the cosine of theta. After you get them entered in, I would go to the zoom and pick trig. It'll give you the better picture. And what you're going to see is the first one it's going to graph is the half circle. It's not really a half circle, but it kind of looks like one. It's going to go out here at 3, but it's going to go around and give you that piece. Then it's going to go down and give you the second piece that's underneath it. Then it's going to jump to the other side because that was the first equation. It's going to jump to negative 3, and it's going to give you this piece, and then it's going to go back up and finish off the rest of it. So this is the first one, this is the second one, the third one, and the fourth one. All right, example 8. We have a butterfly curve, and it is e the sine of theta minus 2 cosine of 4 theta going from 0 to 2 pi. And it said it wants us to follow the Cartesian graph through points A, B, C all the way through O. Oh, okay. I'm just going to graph it on the graphing calculator so we can look at it. So you're going to delete the equations you've got and put this one in. Okay, this one takes a little while to get a nice window. If you get your X window to go from negative 3 to 3 and your Y window to go from negative 2 to 4, you will actually see the very pretty little butterfly that shows up. It's an interesting graph. And once you see it once, if you want to watch it draw it again, just go into the equations and retype the 2 in front of the cosine. Just hit it again, and then it will graph it again for you so you can see the order it's appearing in. But it's really weird the way that it's showing up. It actually starts like this, and then it starts running away. It goes all over the place. Right, let me try that again. The graph, I don't know if I can duplicate it without making a mistake. It goes, starts over here, it goes in, it goes up to there, and then around to here, and then let's see, 4, then it comes down and does the bottom, and then 5, the fifth piece. Then it comes up and gets the big piece. Then it gets this guy. Comes around and gets that one. That's a really poor looking butterfly, but that's the order it goes in. And if you keep going in and changing, you can change, instead of going 0 to 2 pi, if you went pi to 2 pi, oops, you could see the just the bottom half of it being drawn. But it's kind of interesting how it draws it. Okay, now we're going up to example 9. This one, it says, consider the curve described by r equals cosine of 2 theta over 5. Give an interval in theta that generates the entire curve, and then graph the curve. Okay, the easiest way to do this on a calculator is to start out 0 to 2 pi and see what's happening. Go to 4 pi, see if you have the whole picture then. Keep adding portions of it until you get the complete graph. So this particular thing, I believe it takes you all the way out to 10 pi to get the entire graph. And so you can play with that one. Put that one in your calculator. Start out 0 to 2 pi and see just a little tiny bit of the graph that you actually get. And then I said, well, what happens when I go to 4 pi? So I did 0 to 4 pi, and I got a little more of it, and you will notice that it finally completes it when you get to 10 pi. I'm not going to try to draw this one freehand, but you can look at it on your calculator. This completes section 12.2. For this one, I would pick a trig window, go to zoom, trig, and then zoom in just one time, and it'll fill up the whole screen perfectly for you.